The last theorem that we're going to talk about is called the midpoint theorem. Right, so where will this go? This theorem will actually go under triangles. So we talked about lines, angles, triangles, and polygons. Everything that I've talked about before will go under polygons. This idea here will go under triangles. So now you adding to your mind map, right? You adding to this detailed mind map. And the reason that is so critical is because you need to know when to use these things. And don't mindlessly just learn these things. Right, yet again, I will state these theorems as facts. If you're required to prove a theorem, you cannot use a theorem. Right, again, I've talked about it. Theorems, you could either be required to use it, or you could either be required to prove it. So if you're required to prove it, you need to use formal proof or formal techniques to prove it. But for now, I'm going to state it as a matter of fact. The midpoint theorem states that the line segment DE, so let's say we have this line segment here, DE, joining the midpoints of two sides of a triangle. So we have a triangle here, ABC. On the side here, AC, we have a point D, which is exactly in the middle of it. And at this point here, BC, we have a point E, which is exactly in the middle of this point BC. When you join this 2 points together, you get this line segment DE. What happens is, when you have this scenario, so this is what we say. If you have a line segment joining the midpoints of any two sides of a triangle, so DE is joining the midpoints of these two sides of the triangles, what we can conclude is that this line segment is parallel to the third side of the triangle. So we spoke about two sides. The third side, the side that we do not speak about, it's parallel to the third side, and it is equal to half the length of the third side, AB. Let me say that again. If you have a line segment, there's the if, and here's the then. If you have a line segment that joins the midpoints of two sides of a triangle, then this line segment will be parallel to the third side and half the length of the third side. Right, so that's what we can conclude. This is what we can use. What can we use from this theorem? We can use the fact that these sides become parallel and it's equal to half the length. The converse to this theorem is, if you have a line segment, right, that is drawn through the midpoint of not both two sides of the triangle, but one side. So there's one side of the triangle here. This line segment is drawn through it, and see this word here, and it is parallel to the third side. Then the conclusion that we can make is that it will bisect the other side, meaning it will cut the other side of the triangle in half, right? So that's what's extremely important. If this, then that, right? So if you have a line segment running through the midpoint of one side, and the line segment is parallel to the third side of the triangle, then it bisects the second side. Right, so let's go over this again, right? What conclusions can you make from the midpoint theorem? Is that the line segment will be parallel to the third side and half the length. What conclusion can you make from the converse of the midpoint theorem? Is that the second side of the triangle will be cut in half, right? It will bisect the second side. So that's extremely important. As long as you know your theorems, you can use it. So all you're going to be looking for the midpoint theorem is you're going to be looking for a triangle, and you need to look for two sides and a line segment that's drawn on the midpoints of these two sides. And for the converse of the midpoint theorem, you just need to look, you're just going to look for a triangle with a line segment going through the midpoint of one side and parallel to the third. Now, the reason why you need to know the difference between these two is because your reasoning will change. Here, you'll say midpoint theorem. Here, you'll say converse of midpoint theorem. Right? And you get marks for this. So if you need to understand what you're using. Apart from knowing what you need to use, you need to ask yourself, what's the purpose of the midpoint theorem? And you can see already, the fact that we're talking about parallel lines, what do we need to look for? We need to look for transversals. And once we find transversals, then we can talk about angles. The fact that we are talking about parallel lines means that we can introduce what? Parallelograms. So from this topic that comes from triangles, I've already linked it to the topics under lines and the topics under polygons, right? And you can see here that if I go over this mind map that I have here, you can see. So what I can do is I can actually say, if I have to create like a web here, I can do this here. I can say this will link there, and this will link under properties, or it may link under theorems. Can you see that? So this is how we can start interconnecting all of these topics, but it'll get a bit too messy. So let me just leave it as it is. But you need to remember that as soon as you can prove that the parallel lines, then all of these, it unlocks all of these possibilities, right? And then we can move forward from there.